This is a test video using my iPad to make these videos. So just going to go ahead and get started as if I am a student doing this work. So the first problem, find the vertical and horizontal asymptotes. First thing I want to notice here is that I've got a rational function, and a rational function behaves pretty consistently if I can factor the denominator, which I can, and then cancel one of those factors. I notice here that I've got a domain of all real numbers except for 4 and negative 2. So x cannot equal 4 and x cannot equal negative 2. Well, the choice here then is whether we have a vertical asymptote at 4 or negative 2, or whether we just have a hole in the graph. And the thing I remember is if I can cancel the factor that contains that discontinuity, then that means there's a hole. So there's a hole at x equals 4, which means we have a vertical asymptote then at x equals negative 2. So two discontinuities, one's a vertical asymptote, one's a hole. I know it wasn't asking for the hole, but anyway, we got that. So we get the vertical asymptote. What about the horizontal asymptote? Well, if we remember what that means, if the limit as x approaches infinity or negative infinity, plus or minus infinity, of the function f of x, if it's equal to some constant which is less than infinity, then y equals that constant as a horizontal asymptote. Well, as it turns out, if you remember the limits, the limit of this function as x goes to positive or negative infinity is 0. So therefore, we have a horizontal asymptote at y is equal to 0. So that takes care of that problem right there. Okay. And then down here, derivative of f of g of x is, first of all, derivative of the outside f prime of g of x multiplied by g prime of x. Okay. The derivative of 2 to the u is 2 to the u times ln of 2. Log base a of u, it's always 1 over u times ln of the base and multiplied by the derivative of u with respect to x, and I forgot to do that up here. I'm going to call it u prime from now on, du dx. Derivative of inverse sine, let's forget that one, is 1 over the square root of, if it's 1 minus x squared or x squared minus 1, I have to always think about that, or u, so it's 1 minus u squared, and we're going to multiply that by u prime. Okay. Well, the derivative of the inverse cosine, that's just negative 1 over the same thing. 1 over 1 plus u squared times du dx. It's the inverse tangent. I'm going to slide it up a little bit here. Okay. Derivative of the inverse cotangent, well, that's just negative 1 over, so as long as I can remember sine, tangent, and secant, I'm okay, because the other ones, cosine, cotangent, and cosecant, are just the negative, the opposite of what the other ones are. Derivative of inverse secant, well, that's the one where you have a 1 up here. That's just, x. Sorry, I should make these all u's. I'll make those all u's. Is the absolute value of u multiplied by the square root of, now it's the opposite of the sine cosine under the radical, u squared minus 1 multiplied by u prime, and then the inverse cosecant is the opposite of the inverse secant derivative, and then that means that we have a same thing down here in the denominator, absolute value of u, radical u squared minus 1 times u prime. Okay, well, the speed is the absolute value of the velocity. Okay, so we should remember that. Speed's always positive. And I'm going to stop the tape there just to make sure everything's going to work.